your homework today and tomorrow will also be due on Thursday. Okay, so we're going to get into chapter 6, starting with law of sines. This is the law of sines. If we are looking at a picture, we are dealing with a triangle that's not a right triangle. So I'm going to purposely draw a triangle that does not look right. Our angles are capital letters, A, B, and C. The sides across from the angles are lowercase letters. So across from angle B would be lowercase b, across from angle C would be lowercase c. So this law of sines is used for triangles that are not right triangles. If they were right triangles, we would use SOHCAHTOA, or we would use Pythagorean theorem, but we use law of sines if it's not a right triangle. The way that it works is you have this relationship between an angle and the side across from it. So we could write sine of angle A over side A. And then we could relate that to sine of angle B over side B. And we only need 2 at a time. We're just going to be writing a proportion problem that we can solve with cross multiplying. We also use law of sines when we have 2 sides and an angle, or when we have 2 angles and a side. Today we're going to be looking at these 2 scenarios. Tomorrow we're going to be looking at this scenario. This is a little bit more tricky, so we're going to save that for tomorrow. So today we're going to look at when we have 2 angles and 1 side. Either the side is in between the 2 angles or it's not. So here's our first example. We're going to solve this triangle, which means find all the missing pieces. So that means we have to find this side across from angle C. We have to find this side across from angle B. And we have to figure out what angle B actually is. So that's our goal. Let's start with the things we know. So we know this angle A, and we know the side across from angle A. So we could write sine of our angle 48 divided by the side across from it, which is 12. And then we're going to set that equal to another relationship that we can see. So I don't have any information about angle B or side B, but I do have information about angle C, and I can use that to find side C. So I would write sine of 62 divided by the side across from it, which is side C. And now we're going to just solve. We can cross multiply. So we can do C times sine of 48 degrees equals 12 times sine of 62 degrees. And we're trying to figure out what C equals. So if we divide by sine of 48, then we will get C all by itself. Okay, so now type that in your calculator. Make sure that you use the degree symbol. So when you type this in your calculator, you should get 14.26. And you really should try this on your own and make sure you actually do get 14.26. And our sides are measured in meters, so don't forget your units. All right, so we just figured out that C is 14.26. Sometimes it helps to label your picture. Okay, the next thing we could do is figure out what angle B equals, because I know all of the angles in a triangle add up to 180 degrees. So angle B would equal 180 minus 48 minus 62. So angle B is 70 degrees. And now I can use that to figure out what side B is. So I would have to set up another proportion. I can use either the blue relationship or the green relationship, but I would choose the blue relationship because those are given pieces of information that we know are true. If I got side C wrong and then tried to use it to find side B, I'd be using a wrong piece of information to find a new piece of information, and that's just not a good decision. So I'm going to use the relationship of angle A and side A. So sine 48 over the side across from it, 12, equals. And then I just found angle B. So sine of 70 divided by the side across from it, which is side B. And now we're going to cross multiply again to solve. So B times sine 48 degrees equals 12 times sine of 70 degrees. And in order to get B alone, we're going to have to divide by sine of 48. Okay, so type this in your calculator. Make sure you use the degree symbols. You should get 15.17, and that would be measured in meters. So that's B equals. So we found all the missing pieces, these two sides that were missing and the angle that was missing. So that's what you do when it asks you to solve a triangle. Okay, we're going to try this one now. Again, we're going to solve it, so we need to find our missing pieces of information. So angle C we need to figure out, side B, and side A. Those are what we need to find. Maybe what we could do right away is find angle C, because I know that all these angles have to add up to 180. So 180 minus 108 minus 32 will give us angle C. So when you type that in, you get 40 degrees. Okay, and then we have that relationship between angle C and the side across from it. So let's get that set up. So sine of 40 degrees over 14 equals. And then we can either do solving for A or B. It really doesn't matter. Let's do B. How about? So sine of 108 divided by B. Okay, and we're going to cross multiply. So B times sine of 40 equals 14 times sine of 108. And in order to get B alone, we're going to have to divide by sine of 40. Type that in your calculator. Make sure that you are getting these answers correct. But you should get 20.71. And I don't have units, so we'll just leave it like that. And we already found angle C. So now we need side A. So I think I'll go back and I'll use my green relationship again. So sine of 40 degrees over 14 equals. And now we'll do our angle A across from our side A. So sine of 32 degrees over the side across from it, A. And cross multiply again. So a times sine of 40 equals 14 times sine of 32. Whoa, what's happening? I pressed a button and it went crazy. Okay, here we go. 14 times sine of 32. Okay, so in order to get a alone, we have to divide by sine 40. Type that in your calculator. And you should get, for A, 11.54. So we found all the missing pieces of information. We have now solved the triangle. And again, I could not have used Pythagorean theorem or just regular SOHCAHTOA because this is not a right triangle. I don't have any 90-degree angles. Same thing with the last problem. It was not a right triangle. That's why we need law of sines. Okay, this is the last piece. We have, in the past, learned this formula for area of a triangle. Hopefully you recognize that, 1/2 base times height. The base and the height, though, had to be perpendicular to one another. So that's a little bit of an issue if you don't have or you don't know these two perpendicular sides. So, for example, if I had a triangle like this, if I called this my base, then the height would have to be perpendicular. And that could be a little tricky trying to figure out what that height is. Back in geometry, you were probably told what that height was, but you're not anymore. So this old area of a triangle formula might not be the best formula to use. So when you are given two sides and an angle, and the angle has to be in between. So for example, here's angle A. Let's say this is angle B, this is angle C. So this would be side A, side B, side C. Okay, so I'm going to circle. Let's say we knew angle A and we knew these two sides surrounding angle A. Then I could use this formula. So I would take 1/2 times side B times side C times sine of the angle in between those two sides, angle A. All I need are two sides and the angle in between. So maybe I know side B and I know side A and I know the angle in between those two. Then I would be using this version of the formula. Again, it's just 1/2, and then I multiply the two sides together, and then I multiply by the sine of the angle in between the two sides. Okay, or I could know sides C and A and the angle in between them, B, and then I would be using this version. So I wouldn't get too hung up on like the equation itself, just the idea of the equation. It's always 1/2. You multiply the two sides together and then do sine of the angle in between. So that's what I have written right here. So we're going to just practice that. Here's our first example. They did not give us a picture, so we are in charge of drawing the picture. And your pictures don't have to be perfectly accurate. I know angle B is 80 degrees, so maybe I'll try to draw something, close to 80 degrees. But it does not have to be perfect. Maybe I'll call this angle A and this angle C. I know side A is 4, and I know side B is 8. All right, and that's what I know. So if I want to find the area, I need two sides and the angle in between. Right now, I've got these two sides, but I don't have the angle in between. Not yet. but we can figure it out if we do a little work first. I have a relationship. I've got angle B and side B. I know those. And I could find angle A because I know side A. So let's set up law of sines and solve for angle A, and then we'll be able to get angle C from that. So let's do the blue relationship. Sine 80 degrees over 8. And then that'll equal sine A over 4. And then we're going to cross multiply. So 4 times sine of 80 degrees would equal 8 times sine of A. Now this problem is a little different than our past problems because this time we're solving for an angle. These other problems we were solving for sides. So just be a little careful if we're solving for A. First thing we're going to have to do is divide by 8. And then if we want angle A all by itself, we're going to have to do the inverse sine of all of this stuff. Now, if you type that in your calculator, you are going to get, let's see, 0.4924. So again, if you typed all of this in your calculator, that's what you would get. But now we need to do the inverse sine of that in order to get our angle A. And when you do that, you get 29.4987 degrees. So that's angle A. But again, we need angle C because C is between these two sides if we're going to use our new area formula. Well, we know all the angles in a triangle add up to 180. So if I do 180 minus 80 minus 29.4987, I will get 70.5. So angle C is 70.5 degrees. Okay, so now I can use my area formula. So area is 1/2. Let's go back and look. I multiply two sides together and then do sine of the angle in between. So here's my two sides, 4 and 8. And then I multiply by sine of the angle in between those two sides, which is 70.5. Don't forget degrees when you type it in. Okay, so when you type all that in, you should get 15.0823. And remember your units. Our sides were centimeters, so our area would be centimeters squared. Okay. So again, we use this area formula when we don't have a right triangle and we don't have a base and a height that are perpendicular.